morning, this is Mr. Alfonso. Today is February 4, 2020, and we are learning Populations Part 2. So today we're going to finish up populations in our notes and be able to understand how they impact us. So first thing, let's go and write down our essential questions for the day. 1, what is the difference between density-dependent factors and density-independent factors? Give me an example of each. 2, why are there more environmental issues when the age structure diagram is wide? And 3, what will deforestation lead to? So by the end of this lesson, you should be able to answer all these 3 questions. And I'll tell this story when I get in class. And this is what you'll be doing in class today. Now, first thing on this, we talked about this yesterday, but limiting factors, all that means is things that cause a population to decrease in number or size, or it stops them from growing. That's why it's called limiting factors. It limits the population growth, so it stops them from getting bigger. Okay? Now we're going to learn about 2 types of limiting factors today. First one is density-dependent limiting factors. So density-dependent means factors that stop the population from growing if there are too many people in the area. Again, the word density means if there's a lot of people in one small area. So the more the people there are, the more likely people will die from either competition, because there's too many people and not enough water or food, or there's too many people in the area, or too many organisms that will lead to predators wanting to come and eat them. Or, for example, if you're in a big city and there's a disease, if you're in a crowded, really dense population, the disease will be easier to spread, and that will make more people sick, and most likely they will die from that sickness. So if there are more people in the area, and because of that more people will die, that's called density dependent. Again, if there are too many people in the area. Now, we'll come back to that. Next thing is density independent factors. Actually, no, let's go over this real quick. So density dependent, when it gets really crowded, that comes from exponential growth, when the population gets too big. So the larger the population, the more likely density dependent factors will affect everybody, right? Because again, there's more competition for food, gas, living space, etc. And also easier time to spread disease. Now, this is why exponential growth can be a problem, that J-curve, because it leads to all these limiting factors that are density dependent. Now finally, we have this thing called density independent. Now it's going to affect, and it's going to cause people to die regardless if there are a lot of people or not. So whether it's a big population or a small population, this is going to cause population to go down. And examples of density independent factors are weather, like if it gets too cold, or if it's really hot, people might die out in the streets, and that doesn't really matter if there's a lot of people or not. Tornadoes, hurricanes, those are natural disasters. 1, seasonal cycles, and 1, political decision. So 1, if Trump decides to start a war, no matter where you are in America, that's going to affect people, whether you're in an area that has a lot of people or not. I want to emphasize this natural disasters because that leads to the story that I told in class. Basically, when that hurricane hit, it didn't matter if it was a city that was hit or a small town, it still killed people where there were a lot of people and there were not a lot of people. Okay? And so real quick, this year just because you know the differences. Dependent, those are things like resources that depends on the amount of people. Density independent, it doesn't matter if there's a lot of people or not. All right. So, and you'll notice that in most developing countries, population grows exponentially, but you don't need to know that. Here's what you do need to know. We learned this yesterday, but just as a quick review, this is an age structure diagram or population pyramid, where here it's rapid growth because the base is wide. If you notice on the very left, they have a wide base, on average having 7 children per family. That's going to cause the population to grow rapidly. Over here in the middle, where it's about 4 kids per family, that's slow growth. They're still growing, but not quickly. So the government can manage that. This is 0 growth, where they're averaging about 2 to 3 kids per family. and negative growth, they're averaging about 1 kid per family. So what you got to know is write these below your notes, below the pictures, and also write down rapid growth occurs when the base has a large pyramid, like we talked about here. Really any number higher than 5 or more. While this one, negative growth occurs when the base is very thin. So anything less than 2, or anything is at 2. And finally, how is this bad? Because 1, population growth affects environment, because if a population grows exponentially, that means really fast, humans will start cutting down trees to make more space for houses, and here's the effect. Animals lose their houses, so when they lose their houses, they die and they start going extinct. This is known as deforestation. So that brings us to our lesson. When you finish, you should be working on this sheet for practice. But before that, you do need to answer your EQs for the day. So that's our final thing. If you have any questions, please call Mr. Alfonso over. Have a great day.